Hey, unified dumbass here. Today I'm proposing a new type of string in string theory. It's a mechanical string. Fermions and bosons both emerge from this one mechanical object. It has asymmetric boundary conditions on a single string, producing both gravity and collapse. This is done by weak and strong decoherence as the distinguishing mechanism. For example, mass emerges as a non-local effect appearing locally. This is all conceptual. I have no math. Now imagine that both ends of this one string that you are seeing are rotating. Their angular momentum is just opposite from each other. So one is spinning clockwise and the other is spinning counterclockwise. This is supposed to represent the entanglement of two particles in one underlying object. I'm about to show you myself in the factory interacting with this classical analog of entanglement. This is where my idea came from. As you can see, when I interact with the top coil, the paper rips. I interpret that as the wave function collapse. Because of this, upon measurement, I instantly know the spin of both particles. When I interact with the bottom coil, the paper instead warps. Obviously, entanglement is a quantum phenomenon. So as you just saw, interacting with both ends gives us two different outcomes. We had a rip and a warp emerging in between the two entangled particles. Here's a simulation of basically the same thing. By interacting with the unwinding coil on the left, you will eventually create enough tension to rip the medium. Upon interaction, we are localizing the particle on the left. Upon interaction of the particle on the right, all tension is lost. Could this be why gravity is so weak? There is no more tension in whatever space-time is made out of. If we just lightly tap the unwinding coil, we'll get high tension ripples. This is analogous to bosons, such as photons. If you just lightly tap the winding particle, it'll create a dip, changing the geometry of this string. Both of these interactions are non-local from our perspective. Reality emerges from in between these two interactions. We seem to only be able to interact with entangled particles strongly through strong decoherence. We're only interacting with the unwinding particle on the left every time. Our detectors are localizing particles non-locally. They are interacting non-locally. We know that the Higgs is what gives particles mass. So what if the Higgs mechanism is non-locally interacting with this entanglement system, creating our local fermions that we are familiar with? Our reality emerges from these non-local boundary interactions. Here we have a crude simulation of wave function collapse. A wave is simply a string that has zero tension. The coil is very loose. A particle has high tension. It's the same object but localized. When we interact with particles and localize them, this is what we are seeing, figuratively. By randomly interacting with one of the rings of the coil, the rest of the quote-unquote particle will localize around that point. The internal angular momentum will complete this interaction, creating a localized particle. It looks random, but we are just selecting a location on one of these rings. The more spread out this coil-like, wave-like object is, the more random locations there are to choose from. If I were the Higgs mechanism and this was an electron, this would be completing the other half of the entangled interaction. If the Higgs mechanism strongly interacts with the winding particle, it'll create immense curvature and warping, analogous to a black hole. The angular momentum of the entangled particles at the event horizon of a black hole has completely stopped at this point. This is analogous to extreme time dilation for observers outside the event horizon of a black hole. Because this string is mechanical, it has directionality. Graphically, light is represented at a 45-degree angle in special relativity to show the relationship between space and time. This mechanical string seems to represent both quantum mechanics and general relativity at the same time in one underlying object, just looked at from a different mechanical perspective. This is a bottom-up approach for gravitizing the quantum. Again, this is just all conceptual, and as unified dumbass, I don't really know what I'm talking about. I just wanted to share the idea. I hope this made sense, and I hope that it could be useful for somebody someday. That'd be really fucking cool. Anyways, unified dumbass is out of here. Peace.